Yes, this is Mr. White.
And Mr. Sadler.
And today we're going to do a little AP Plus, Chapter 2, Section 3, and Vector Math. Woohoo!
Yeah.
Trigonometry. Trigonometry. One of the scarier words for high school math. Triangle trig, but it applies to physics. It applies to a lot of things, so let's just get right to it. We're looking at pages 168 and 169 of your textbook, and we're going to start with some basic stuff.
Adding vectors by.
Adding vectors that are in the same direction.
All right.
Okay, so let's say I have, we're talking about force today, so let's do force.
All right.
Let's say I have a force vector that is 30 newtons to the right. And I have a second force vector that is 40 newtons to the right.
Okay.
I want to know the sum of the vectors. And here, it is as simple as it looks.
Just adding them together.
Just adding them together.
Because they're both right.
This is 30 to the right. And this is 40 to the right.
Right.
Then my sum total is 30 plus 40, 70 newtons to the right.
So really what you did is you just took the tail to the head of the previous one and just added them together that way.
The tip to tail method there.
Yep.
So I take the end of one vector to the beginning of the next, and I add them together. That method always works. I don't recommend that you get out a ruler and measure and scale. That's a disaster. I do recommend, in the more complicated case, you do some trig.
It would give you an estimate, though. It would give you some idea if you figured out that, oh man, I'm way off.
It does.
So what am I doing
it
right?
does a nice job of giving you a ballpark.
Right.
That's the simplest case. The next case would be, hey, what if?
One to the east and one to the west.
Yeah. What if we have 30 newtons to the east? So here's just another direction that we could be using. But in this case, we have 40 newtons to the west.
All right. So I know that the west is negative. Okay.
Okay. So I know that I've got 30 newtons
to the east
here, and it's still the same tip to tail method. So I come back across like this, and I go 40 newtons to the west.
Right.
Well, they're in opposite directions. So the way to do this, of course. So let's draw my vector. I know what the answer is. I know you know what the answer is, but let's just look at this. So if I'm going to go 30 to the right plus negative 40 because it's opposite,
correct,
then my answer is
negative 10.
Negative 10. Negative 10 happens to be 10 newtons to the west or left, depending on how you want to work this.
Right.
Would this method work if our vectors were pointing up and down?
Absolutely. If one was up and one was down?
Yeah, or north and south?
Correct.
Right. So we can have, we're just going simple case.
Anything. So where they're both going the same way or they're going opposite ways, pretty easy so far. Same
plane is what we had here and here. That's easy. What if they're not? What if we have different planes of motion?
So like one north and one west or something like that.
Sure. I'm gonna make it a little easier on us, Mr. Sadler. I'm gonna go one east, one north.
Okay.
And we'll talk about why we do that. We're gonna go. Let's see. Yeah, 30 newtons to the east, or to the right, whatever you prefer. We're gonna go with our second vector to be 40 newtons
to the north.
To the north, or up, however you want to describe it. And we want to know the sum of the vectors.
So this is really, when they say as the crow flies, this would be tip to tail here.
Tip to tail. The first thing I need to do is draw a coordinate plane. Now, I know that if one's going right and one's going up, or one's east, one's up, I know that my answer is going to be in quadrant
so like northeast
1, or in the general northeast-ish direction.
Mm-hmm.
So here we go. So 30 to the right, followed by 40 to the north. I still go tip to tail.
Right.
And then I draw it out. This is often called the resultant.
This is also we talked about this situation before. I'm swimming across the river, but the river's flowing to the right.
Yeah.
It's the same thing.
It's the same exact thing, and those were vectors too. Now, when I do this, I notice that I have something convenient. I have two convenient things, actually. What kind of triangle do I have here?
Right triangle.
I have a nice right triangle, and specifically I have a...
Yeah, that golden triangle that we talked about before.
The 3, 4, 5.
Yep.
So I know the answer is 50, but we could do the math, right? Okay, so one leg of my triangle, 30 squared, plus the second leg of my triangle and square it, is the resultant squared.
Right.
So I take the root of everything. 30 squared is 900, 40 squared is 1600, sum is 2500.
Square root
is
50
newtons. But I don't quite have a direction yet.
Right.
I have to do some cosine, sine, or tangent. Now I'm going to recommend tangent because these numbers were given in the problem, and tangent talks about opposite
over
adjacent. If I got the wrong answer here, I will get the wrong angle. So I don't want to use the resultant in my calculations. So the tan of the angle, which we're going to call theta, okay, is opposite over adjacent. So on the next screen, all right, if I want to, let's rewrite that, except this time I'm going to, opposite was 40, adjacent was 30. If I want to clear tangent, I have to do the opposite math function of that, or the inverse function. So if I take the tan inverse of both sides of this, then I'm left with theta is tan inverse of 40 over 30. When I plug it into my calculator, by the way, degree mode. When I plug it into my calculator, okay, I'm going to get the tan inverse of 1.33, or 53 degrees.
So I'm 53 degrees off there. Absolutely.
Right. So back to my drawing, is this roughly 53 degrees?
Absolutely.
It is in quadrant 1. So I said I've picked something easy. We come to our math lesson of the day. Quadrants 1, 2, 3, and 4. All right. So what do we got? Positive x, positive y.
Right.
So east and north, right and up. I've got negative x, positive y.
Right.
West and north, left and up.
Negative and negative.
So I'm west and south, or left and down. Or I got positive and negative. So I'm right and down. I'm east and south. The only way we can use the words northeast, southeast, etc. is if it's exactly at a 45-degree angle.
Right.
All right. You've learned some of this in Algebra 1 and in Algebra 2 and in Trig class, but we're going to see how it applies to math. Your homework then tonight is to do number 1 and number 2 on page 169.
So we're going to add some vectors.
Absolutely.
Okay.
Wrapping things up and signing off, this is Mr. White.
And Mr. Sadler.